In this video, we are going to use the Laplace transform to solve this differential equation with initial value condition. Right. So, if you can recall from my previous video, we derived the Laplace transform of the derivatives of the functions. So, we are going to recall them now. We have the Laplace transform of the first derivative of y with respect to t, and this is s times the Laplace transform of y of t minus y of 0, and this one is the initial condition. And the Laplace transform of the second derivative, that is y prime prime of t, this one is equal to s squared times the Laplace transform of y of t minus s times y of 0 minus y prime of 0. Right, so we derived this one in my previous video. So what we are going to do is to use these ones to solve this differential equation with initial value condition. So let me go ahead and do that. So for us to solve this differential equation, we will have to take the Laplace transform on both sides. So let's do that. So we are going to take the Laplace transform of y prime prime of t minus 6 times y prime of t plus 5 times y of t. This is a differential equation, and this one is equal to, you take the Laplace transform of the right hand side as well to maintain equality. Alright, so now applying the linearity property, you can work this one as the Laplace transform of y prime prime of t minus 6 times the Laplace transform of y prime of t plus 5 times the Laplace transform of y of t, and this is equal to the Laplace transform of t. Alright, so everything is now falling into place. So the Laplace transform of y prime prime of t, this one is equal to what we have here. Right, so this is what we have here. So we are just going to replace y prime prime of t, the Laplace transform, with, this is going to be s squared times y of s minus s times y of 0 minus y prime of 0. Those are the initial conditions. Minus 6 times the Laplace transform of y prime of t, which is what we have here, and that is equal to s times the Laplace transform of y of t minus the initial condition, like this, and now plus 5 times the Laplace transform of y of t. So the Laplace transform of y of t, that one is capital Y of s, and this is equal to the Laplace transform of t, that is t raised to the power 1, and which is 1 factorial divided by s raised to the power 1 plus 1. Alright, so this is what we have. So now we have to plug in the initial conditions. So y of 0 is 1 and y prime of 0 is 0. So we just replace this one with 1 and this one with 0. Alright, so now let's do that. So this is s squared multiplied by y of s minus this one is s times 1, which is s. And now this is 0, so there's no need to write that, minus 6 into, this is s times y of s, and now minus this one is 1 from the initial conditions, plus 5 times y of s, and this one is equal to 1 over s squared. That is a Laplace transform of t. Cool stuff. So now here, what do we have? We can gather like terms here. So this one is now going to be s squared multiplied by y of s minus 6s multiplied by y of s, and now plus 5 times y of s. Alright, and now we have minus s and then plus 6. So because this negative and this negative, when we multiply, then that becomes positive 6, and that is equal to 1 over s squared. Cool, so now we can take these ones to the right hand side. So but then we have to factorize y of s here, the Laplace transform of y of t, and this is left with s squared minus 6s plus 5, and this one is equal to 1 over s squared plus s minus 6. That is taking these ones to the right hand side. Now we have to simplify this one. So on the right hand side, you are going to get this one is going to be s to the third minus 6s squared, and now plus 1 all over s squared. That is just multiplying by the LCM, which is s squared. So now we will have y of s, and this is multiplied by, this one is a quadratic term, so solving it quadratically, we are going to get s minus 1, and this is multiplied by s minus 5, like this. So this is what we have. And now this is equal to the right hand side, which is s to the third minus 6s squared plus 1. All this one is divided by s squared. So now let's try to isolate this one. So we are going to divide both sides by this. And when we do that, we are going to get y of s, the Laplace transform of y of t, and that is equal to s to the third minus 6s squared plus 1. This is divided by s squared multiplied by s minus 1, and this is multiplied by s minus 5, like this. We are going to take the Laplace inverse on both sides. So the Laplace inverse of capital Y of s, and we are doing the same thing to the right hand side, the Laplace inverse of this, which is s to the third minus 6s squared plus 1. This one is divided by s squared into s minus 1. This is multiplied by s minus 5, like this. So the Laplace inverse of y of s, so we are going back. So this one is now going to return y of t in the t world, and this is equal to what we have here. So we will now have to solve the Laplace inverse of this function, which is s to the third minus 6s squared plus 1 all over s squared into s minus 1 multiplied by s minus 5, like this. So this is what we have. So now up until this point, we have used the Laplace transform to transform this one into a solution of y of t, which involves the Laplace inverse of something like this. So the task now is to use the Laplace, to use like partial fractions to break this one down into several fractions and then apply the linearity property. So I'll go ahead and do that right now. So we are going to use partial fractions like s to the third minus 6s squared plus 1 divided by s squared into s minus 1 into s minus 5. This one, using partial fraction decomposition, we are going to have a over s, right, plus b over the second one, which is s squared, plus c over s minus 1, and now plus d over s minus 5, like this. So this is what we have. So we will have to find a, b, c, and d. When we find that, then this question becomes trivial. We can easily take the Laplace inverse of all these guys separately. So we are now going to solve this one to find the values of a, b, c, and d. So the LCM here is what we have, s squared times s minus 1 times s minus 5. And now let's divide. So this one divided by this, that is s multiplied by this guy. So that is going to be a into s multiplied by this guy, and that is s squared minus 6s plus 5, like this. All right, plus b. This one divided by this, we are going to get these ones. So that is going to be left with s squared minus 6s plus 5, like this. All right, we are moving on, plus c, and c, the LCM, this one divided by this, that is going to be left with s squared, right, multiplied by s minus 5. And now plus d, the last one, this one divided by this, that is going to be s squared times s minus 1. Cool. And now the left hand side is going to be s to the third minus 6s squared plus 1. This is divided by s squared into s minus 1 into s minus 5. Cool stuff. So now here, what do we have? Now the denominators are the same. When we multiply by the denominator, they will cancel, and now you are left with the numerator. So the numerator is going to be s to the third minus 6s squared plus 1, and that is equal to, now let's FOIL these guys. So that is going to be as to the third minus 6as squared plus 5as. We are done with the first one. Now this one is going to be plus bs squared minus 6bs plus 5b. Next one is going to be plus cs to the third minus 5cs squared, and now plus gs to the third minus gs squared, like this. So this is what we get after expanding. Now let's gather like terms. S to the third minus 6s squared plus 1 on the left, and this is equal to, now let's gather the third, s to the third term. So that is going to be a plus b plus d, right? So a plus b plus a plus Is B is C? I'm sorry about that. So it's A plus C plus D. So this one is S to the third minus, what about the S squared terms? That is going to be negative 6A plus B, right? And now minus 5C minus D. So this is what we have after the expansion. Now what about the S term? The S term is going to be 5A, which is what we have here, 5A and then minus 6B, and that is all that we have, and this is S. Now the constant term is just only one, that is 5B here, so plus 5B. So this is what we have after grouping like terms. So now we can compare both sides. So by comparison, we have A plus C plus D. This one is equal to 1. The coefficient of S to the third on the left is 1. That is what we have here. Now this is equation 1. What about equation 2? That is negative 6A. This one is positive, I beg your pardon. So negative 6A plus B minus 5C minus D. This one is equal to negative 6. That is the coefficient of S squared on the left hand side. You can call this one equation 2. Now what about equation 3? Equation 3, 5A minus 6B, that is coefficient of S on the right hand side. On the left we don't have the coefficient of S, and that is equal to 0. You can call that equation 3. And now the constant term on the right hand side is 5B, and the constant term on the left hand side is 1. So that is what we have. This is equation 4, right? So from equation 4 we can already find what B is. So B in this case is just 1 over 5 from equation 4. So we have found B from equation 4. Now we can plug that into equation 3 to find the value of A. So now let's do that. Alright, so here from equation 3, 5A minus 6B is equal to 0. So that means that 5A is equal to 6B. So this is what we have, and that means that A here is equal to 6B all over 5, like this, implying that A is equal to 6 over 5 times B, and B is 1 over 5, which is what we have here. And that is simplifying to what, 6 over 25, like this. So that means that B is equal to 6 over 25. So let me just put them here in yellow pen for easy identification. So A is 6 over 25. We have gotten that, and B is equal to 1 over 5. Now let's find the values of C and D. So to find the values of C and D, we can plug them into equation 1 and equation 2. So for equation 1, this equation, so A plus C plus D. A is, that is from here, we are continuing from here. A is 6 over 25. This is what we have, plus C, and now plus D. This is equal to 1. Right, so C plus D is equal to what? So C plus D is equal to 1 minus 6 over 25. And that is equal to 25 over 25 minus 6, and that is going to be 19 over 25. So 1 minus 6 over 25 is 19 over 25. Right, so maybe you can call this one equation 5. Why not? Because we'll have to come back to it. Now let's plug the values of A and B into equation 2 again. Right, so from equation 2, plugging the values of A and B, so we have negative 6A. So negative 6 times A. A is 6 over 25, like this, plus B. B is 1 over 5, like this. And now minus 5C minus D. This is equal to negative 6. So now let's try to simplify this. This one is negative 36. Right, so this one is going to be, I'm going to continue from here, negative 36 over 25 plus 1 over 5. 1 over 5 can be written as 25 over 5 over 25. I'm sorry about that. 5 over 25. That is 1 over 5. And now minus 5C minus D. That is equal to negative 6. So we can easily sum these ones. And doing that, that is going to be negative 31. Right, so that means that we are going to have negative 5C minus D, and that is equal to negative 6. This one is going to be negative 31 over 25, and that is now going to be positive 31 over 25 on the right hand side. Right, so when we sum this one, this one we are going to get so negative 5c minus d. This is equal to, so multiply top and bottom by 25. This one is going to be negative 150 all over 25. That is negative 150 over 25 is negative 6. And now plus 31 over 25. Plus 31 over 25. Right, so that means that negative 5c minus d, that is equal to negative 150 plus 31, that is going to be negative 119 all over 25, like this. So maybe we can call this one equation 6. Why not? So now let me switch colors, enough of blue. So we are now going to solve equation 5 and equation 6 for c and d. Equation 5 and equation 6 for c and d. So now let's do that. But before we do that, let me not call this one equation 6 yet. I want to make all of them positive, so I'm just going to multiply both sides by negative 1. When I multiply both sides by negative 1, that is going to make all these ones positive, right? So that is one is going to be 5c. So multiplying both sides by negative 1, that is going to be 5c plus d, and that is going to be equal to positive 119 over 25, like this. So this is equation 6. I hope it's clear. So now let me now solve these two equations simultaneously. So I'm going to do equation 6. So equation 6 minus equation 5. So when we do that, 5c minus c, that is going to be 4c. And then d minus d, that is going to be 0 straight away. So that is going to be 4c to be equal to 119 over 25 minus 19 over 25. That is going to be 100 over 25. And 100 over 25 is equal to 4. So 4c is equal to 4. That implies that c is equal to 1. Alright, cool. So now the value of c is equal to 1. We can just plug that here to find the value of d. So c plus d is equal to 19 over 25. Right, so c plus d. C plus d is equal to 19 over 25. So that means that d is equal to 19 over 25 minus 1. And that will be the value of d, and that is going to be negative 6 all over 25, like this. Alright, so now we have gotten the values of a, b, c, and d. Now let me write all of them in yellow. So the value of a is equal to, that was a long one, a is 6 over 25. A is 6 over 25. What about b? B is 1 over 5. That's the first one we found. C is equal to 1, a very simple one. And d is equal to negative 6 over 25. Exactly opposite of this. So we have gotten values of a, b, c, and d. Now let's go back to our partial fractions. So now going back to our partial fraction, this is where we are coming back. We are going back to this one. So s to the third, right? S to the third minus 6s squared plus 1 all over s squared into s minus 1 multiplied by s minus 5. This one can be broken down into this. That is this one here can be broken down into this. So that is a over s plus b over s squared. So a over s, a is 6 over 25. So 6 over 25 over s, that is the same thing as 6 over 25 times 1 over s, like this. Plus b over s squared, b is 1 over 5. That is going to be 1 over 5 over s squared. That's the same thing as 1 over 5 times 1 over s squared. Right, this is 5. Alright, now the next one is going to be plus c over s minus 1 plus d over s minus 5. So plus c, and c is 1. So plus 1 over s minus 1 plus d over s minus 5, and d is negative 6 over 25. So negative 6 over 25 over s minus 5 is the same thing as negative 6 over 25 times 1 over s minus 5, like this. So this is how we can break it down using partial fractions. And now the beautiful thing here is that we now have to take the Laplace inverse of that, which is what we have here. So let me switch back to white pen and then we can finish off with this. So y of t is the Laplace inverse of this guy, which is s to the third minus 6s squared plus 1 divided by s squared into s minus 1 into s minus 5. And this is the same thing as the Laplace inverse of what we have, which is 6 over 25 times 1 over s plus 1 over 5 times 1 over s squared, right, plus 1 over s minus 1 minus 6 over 25 times 1 over s minus 5, like this. Alright, so now we are now going to apply the linearity property. So our solution is just the Laplace inverse of this guy, which is, the first one is going to be 6 over 25. We are going to have the Laplace inverse of 1 over s. Very simple. Plus 1 over 5 is a constant. We are going to have the Laplace inverse of 1 over s squared. Right. The next one is going to be plus the Laplace inverse of 1 over s minus 1. Next one is going to be minus 6 over 25, a constant, then the Laplace inverse of 1 over s minus 5, like this. So now we know all this. So this one, the Laplace inverse of 1 over s is 1, because the Laplace transform of 1 is 1 over s. So this one is 6 over 25 times 1. That's the Laplace inverse of 1 over s. This one, the second one, if we can recall, right, so the Laplace transform of t, right, this one is going to be 1 factorial divided by s raised to the power 1 plus 1. So this is the same thing as 1 over s squared. So that means the Laplace inverse of 1 over s squared, this one is going to return t, right? So now we just have to know all these ones before we can apply the Laplace inverse. So this one is plus 1 over 5, and now the Laplace inverse of this one is going to be t. Plus, what about this? The Laplace inverse. So the Laplace transform of e to the at, this is 1 over s minus a with s strictly greater than a. That implies that the Laplace inverse of 1 over s minus a, this is going to return the exponential function e to the at. So this is what we have. And now for the third and the fourth one, the Laplace inverse of 1 over s squared, 1 over s minus 1, a in this case is 1. So this is going to be e to the 1t minus 6 over 25, a constant, and now multiplied by the Laplace inverse of 1 over s minus 5, which is e to the positive 5t, like this. Alright, so this is the answer to our differential equation. So y of t is going to be 6 over 25 times 1, which is 6 over 25, plus t over 5, right, plus e to the t, minus 6 over 25 times e to the 5t. This one is the answer to our differential equation with initial value problem. Right, so the majority of the work was just in trying to find the Laplace inverse, and then we will have to find the constants a, b, c, and d. I could have given you these constants, but I just wanted to walk through on how to solve these ones simultaneously to find the values of a, b, c, and d. So after finding them, then the Laplace inverse is trivial. Just take the linearity property of the Laplace inverse, and then you apply it to all the four, and then this one is the answer to our differential equation. You can verify it by differentiating this one twice and differentiate it again. So when you differentiate it for the first time and the second time and you plug it back into our differential equation, you see that the left hand side is going to be equal to the right hand side. And that is by solving this one using the Laplace transform. Right, so if you find this video helpful, give me a thumbs up and subscribe to Calculus Diaries, and I'll see you in my next one. Bye bye.